Was just exploring some Google Maps, what I do on my free time, and look at this. Pac-Man in Google Maps? What? This is crazy. So I suggest you check out Google Maps, and for some reason you can play Pac-Man right now. So let's look at some Unit 12 test questions. And a lot of this unit we'll need our reference sheet for. So the first example here is a perfect example of where we'd use the reference sheet. We want to know what the expression cosine of 70, cosine of 10, plus sine of 70, sine of 10 would be. 70 and 10 are not any of those exact values, the 30, 45, or 60. But realize that this is similar to a sum or a difference of two angles. And if we make 70A and we make 10B, then it's cosine of A, cosine of B, plus sine of A, sine of B. And let's go ahead and take a look at our reference sheet. So we're looking for cosine of A, cosine of B, but we want plus. So that's right here. Cosine A, cosine B, plus sine A, sine B. So that turns into cosine of A minus B. So now if we just substitute back in the numbers, 70 is A, 10 is B, we get cosine of 60. So that would be our final answer. And if we really didn't know how to do this, what we could do is just substitute in cosine of 70. We can put all of that in the calculator, get a numerical value. So let's just do that maybe real quick. Make sure we are in degree mode. So cosine of 70, cosine of 10, plus sine of 70, sine of 10. We get a numerical value of 1/2, and we know the cosine of 60 is 1/2 as well. So if we really didn't know how to do it, we could use our calculator. This question tells us that theta is an angle in quadrant 1, and they give us trig function, second degree trig function. We want to know what the value of theta is to the nearest degree. So if we want, we could do a let statement. So let tan of theta equal x. If that helps you out, you can certainly do that. So wherever we see a tan of theta, we'll replace it with x. So tan squared theta, so we have x squared. Okay. Now you could add the 40 to both sides and take the square root of both sides, or realize that we could do dots here, difference of two squares. So we get x equals 2 and x equals -2. But we need to go ahead and replace x back with tan of theta. So tan of theta equals 2. Tan of theta equals -2. Now we want to solve for theta, so we can go ahead and do inverse trig. So theta equals tan inverse of 2. So now this is where we need to use our calculator. So make sure, again, you're in degree mode. Second tan of 2, and hit enter. So we get 63 degrees. So 63 degrees is also our reference angle. Tangent is a +2, so we could be in quadrant 1, or we can be in quadrant 3. If we were in quadrant 3, we would do 180 plus 63, which is 143. So we have two answers for that side, and we are actually done. Here is the answer, but let's just keep going here. So theta equals tan inverse of -2. So again, we'll use our calculator. Second tan -2, and we get theta equals -63. So just realize that the reference angle is still 63 degrees, but since theta is, Since tan of theta is a negative, this time we are in two different quadrants. This time we're in quadrants 2 and 4 because that is where tangent is negative. So if we're in quadrant 2, we would do 180 minus the reference angle. If we're in quadrant 4, we would do 360 minus the reference angle. 180 minus 63 and 360 minus 63. So those are our other two angles. So here we get theta equals 117 and theta equals 297. Okay, so we had 4 answers. Really, it's just asking us, we really had it right in the beginning with 63, but that's fine. If it was a part 2 question, that is how you get all 4. The expression sine of 180 plus x is equivalent to. So we have a sum of 2 angles. 180 is an angle and x is an angle. So sine of 180 plus x, or a plus b. So let's go ahead and look on the reference sheet. So go ahead and pull that up. And we're looking for sine of a plus b, which is right here. So that turns to be, so sine of a plus b, we can change to, it is equivalent to sine of a cosine of b plus cosine of a sine of b. So now a was 180, so wherever we see a, let's replace it with 180. And b was x, so wherever we see b, replace it with x. Now hopefully you realize that 180 degrees is a quadrantal angle, and quadrantal angles you can put in the calculator and get a value, or you can use your unit circle. So sine of 180 is 0, and cosine of 180 is -1. So we have 0 times cosine of x plus -1 times sine of x. Anything times 0 is 0, so we are left with negative sine of x. We want to know what this is equivalent to. Hopefully you could see that we have a double angle. So again, we're going to go to our reference sheet. A lot of this is going back and forth between the reference sheet. So what's nice here is we only have one option. Sine of 2a, we can only change that to one thing. So sine of 2a, we could change that to 2 sine of a cosine of a. Now cosecant of a, probably want to change that to 1 over sine of a. Let's put this over 1. Now when we multiply, we can multiply straight across. So 2 sine a cosine a divided by sine of a. And then sine of a divided by sine of a, that reduces to 1, and we're left with just 2 cosine a. Choice 3. Cosine of 270 minus a. So think of this as a, and still think of this as b, even though it's really an a here. We have a difference of 2 angles, cosine of a minus b. So once again, go to that reference sheet. Right here, cosine of a minus b. So this, cosine a minus b, is equivalent to cosine of a, cosine of b, plus sine of a, sine of b. Okay, replace a with 270. Replace b with a. And once again, 270 is a quadrantal angle, so we can use our calculator. Cosine of 270 is 0. Sine of 270 is -1. So anything times 0 is 0. So it looks like we're left with negative sine of a. So we want to solve for x. Okay. Our goal is to get the trig function by itself. So we have a radical here. The inverse of square rooting is squaring both sides. So we can go ahead and do that. And we have 2 sine of x plus 7 equals 9. Now let's go ahead and subtract 7 from both sides. And divide both sides by 2. So we have sine of x equals 1. Okay. At this point, we'll go ahead and do the inverse. So x equals sine inverse of 1. And we get 90 degrees. But you need to realize that 90 degrees is a quadrantal angle. So yes, that is one answer, but it might not be the only answer. So we talked about the 2 different ways that you could do this. First way we'll take a look at is a little more mathematical, where we use our unit circle. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so the point xy on the unit circle is cosine of the angle, comma, sine of the angle. We want to know when sine of the angle is 1. So we're really looking for our y-coordinate. We're looking for when our y-coordinate is 1. And the y-coordinate is 1 at 90 degrees. So 90 degrees is our answer, and that happens to be our only answer here. So x equals 90. The other way that we talked about was taking all the quadrantal angles. So here is 0 and 360. Here's 90, 180, and 270. And just cycling through in your calculator all your quadrantal angles. So sine of 0 is 0. We're looking for when sine of the angle is 1. Sine of 90, we know that's going to be 1, and it is. Sine of 180, that's not going to work. Sine of 270, nope. And then sine of 360 is the same as sine of 0, so that doesn't work either. So that is the only choice, 90 degrees. But you do need to be aware that you could have one answer, you could have 2 answers, or you could have 3 answers for your quadrantal angles. Find the value of x, and they're only asking from 0 to 180 degrees. Normally you see 0 to 360. This one happens to only be 0 to 180. Okay. So looking here, we could factor out a cosine. If we want to do a let statement, we certainly can. So since x is already being used, we don't want to use it again, so maybe let's use a. Let a equal cosine of x. So wherever I see a cosine, I'll replace it, cosine of x, or replace it with a. So we have a squared minus 2a equals 0. So if that helps you see it a little better, you can certainly do that. We have a GCF here. We have a GCF of an a. So a minus 2 equals 0. Set both factors equal to 0. Okay, now since we fully solved, let's go ahead back and replace it with cosine. So cosine of x equals 0. Cosine of x equals 2. So once again, realize that this is going to be a quadrantal angle here. So x equals cosine inverse of 0. Certainly use your calculator here. And we get 90 degrees. Just going to go back and grab this. Okay, so this time, since we have cosine, we're looking at our x-coordinates. So x, we're looking for when x is 0. And x is 0 at, let's see, x is 0 at 90 degrees. So x equals 90 degrees. And it's also 0 at 270. So this is where we have 2 answers here. X equals 270 degrees. That's why it's really important to realize when you have a quadrantal angle, you could have more than one. We could even confirm that. Cosine of 90, that equals 0. Cosine of 270, That's also going to equal 0. Okay, so now let's do this side. X equals cosine inverse of 2. And we're going to get an error in our calculator. It's going to be a domain error. Error domain. The reason why is because cosine graph goes from 1 to -1. Whoops. So it's outside the domain. We get an error, just disregard it. So our only answers are 90 and 270, but we need to make sure we answer the question. It says find the value of x in the interval 0 to 180 degrees. So we're actually only going to say x equals 90 degrees because that's the only one in the domain from 0 to 180. So we're told a lot of information with this question. The sine of some angle is -8/17, and that angle lies in quadrant 3. The cosine of another angle is -4/5, and that angle lies in quadrant 2. But we want to know what cosine of x minus y is. So we have a difference of two angles, so right away we know to go to our reference table. So a difference of a minus b. So x is a, y is b. So we can go ahead and look here, and there we go. So this is equivalent to cosine of a, or cosine of x, I should put it. Cosine of x, cosine of y, plus sine of x, sine of y. Now let's just go ahead and replace what we have. We know what sine of x is. So sine of x is -8/17. We know what cosine of y is. Cosine of y is -4/5. So it's just a matter of figuring out what cosine of x is and what sine of y is. Well, we can do that. If we want to know what cosine of x is, we need to take our information about angle x. So angle x we know lies in quadrant 3. So angle x lies in quadrant 3. And the sine of that angle is -8/17. So the opposite is 8. The hypotenuse is 17. Since we're moving down, on the y-axis it's -8, and the hypotenuse will always be positive. So at this point, we want to find this missing side. We would go ahead and use the Pythagorean theorem. -8 squared plus x squared equals 17 squared. Okay, and we get 15. So now we just need to be aware that if we're moving to the left on the x-axis, then this is going to be negative. Okay, so now we know what cosine of x is. Cosine is adjacent over hypotenuse. So -15 divided by 17. Now let's go ahead and figure out what sine of y is. And again, we'll use our information about angle y. So angle y lies in quadrant 2. And cosine, or adjacent over hypotenuse, the adjacent is 4, the hypotenuse is 5. And this would be -4 because we're moving to the left. This is a 3, 4, 5 triangle. So the opposite side is 3, and it's positive because we're moving up on the y-axis. So that means then that the sine of y is 3/5. At this point, we can just use our calculator to evaluate all of this. So -15/17 times -4/5 plus -8/17 times 3/5. Okay, put that all in, and we get 36/85. So here we're told cosine of x equals 1/8, and x is an acute angle. So that tells me that the angle is in quadrant 1. It's a positive acute angle. and we want to find the value of cosine of x divided by 2. Well, that's the same thing as cosine 1/2 x. Now we have our half angle identities, so we'll go ahead and once again look at our reference sheet. So cosine half of an angle is plus or minus, and remember, we're only going to choose one of them. So if we're in quadrant 1, all of the trig functions are positive. So that means we'll choose the positive. Okay. So we have positive square root of 1 plus cosine of x divided by 2. At this point, we're good to go because we know what cosine of x is. So we can just go ahead and put that all right in. So now what we should do is just put in underneath the radical first, because we don't know if we'll have any irrational numbers at the end. So let's just do that. Whoops. Okay. So 1 plus 1/8 divided by 2. That gives us 9/16. So now we have the square root of 9/16, which is 3/4. Find to the nearest degree all values of x, all values of theta, in the interval 0 to 360 that satisfy this equation here. So we have a little bit of a problem because we don't have a single trig function. We have a sine and we have a cosine. So we have to somehow get them to be single trig function, whether we change everything in terms of sine or we change everything in terms of cosine. Now, I see a sine squared. Now, when we're dealing with trig functions squared, you should think about your Pythagorean identities. So our most basic Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Well, then that means that sine squared theta is the same exact thing as 1 minus cosine squared theta. So at this point, if I replace sine squared theta with 1 minus cosine squared theta, that's okay because they are equivalent. So I have 2 times 1 minus cosine squared theta plus 2 cosine theta minus 1 equals 0. So we'll distribute this out. Let's combine like terms. Okay. Now it's going to probably be better to bring everything over to the right side to make our leading coefficient positive, or we can multiply both sides by a -1. By doing that, now we have positive 2 cosine squared theta minus 2 cosine theta minus 1 equals 0. Just always a good idea to have your leading coefficient be 1. At this point, let's do a let statement. So let cosine of theta equal x. And wherever we see a cosine of theta, replace it with x. 2x squared minus 2x minus 1 equals 0. Okay, we could see if this is factorable, but it's not going to be. So if it's not factorable, what we have to do is either complete the square or do the quadratic formula. So quadratic formula will probably be better for this question. Quadratic formula, x equals -b plus or minus square root of b squared minus 4ac divided by 2a. So 2 is a, -2 is b, and -1 is c. So let's just substitute in. So -2 is just 2. -2 squared minus 4 times 2 times -1 all over 2 times 2. Okay, so negative 2 squared is 4, plus 8 all over 4. Okay. And if we wanted to simplify radical 12, we could do that. Radical 4, radical 3, or 2 radical 3. So x equals 2 plus or minus 2 radical 3 divided by 4. Then we could simplify that even further to make it x equals 1 plus or minus radical 3 over 2. So we have two separate answers. X equals 1 plus radical 3 divided by 2, and x equals 1 minus radical 3 divided by 2. So now we want to, since we solved for x, we'll go back and replace x with our original trig function, which was cosine of theta. So we have cosine of theta equals 1 plus radical 3 divided by 2, and cosine of theta equals 1 minus radical 3 divided by 2. So now let's use inverse trig. So theta equals cosine inverse 1 plus rad 3 divided by 2. Go to our calculator. Cosine inverse 1 plus rad 3 divided by 2. And we get an error, domain error. So that means that, we did a question before, that means that it's outside of the range of 1 and negative 1. Okay, so we actually have an error here. That's great. We could just move on. Domain error. So let's move on to the other side. So second cosine. And we'll change it to a negative in the middle. Okay. So we get theta equals 111, and what were the rounding directions? To the nearest degree. So 111 degrees. Now, we need to figure out that reference angle. So if it's in quadrant 2, 180 minus 111, and that reference angle is going to be 69 degrees. Now this is important because we need to figure out whether cosine is positive or negative. 1 minus radical 3 divided by 2 is negative 0.13. So this here is negative, 0.366 and so on. So that means that cosine is negative. Cosine is negative in quadrants 2 and 3. We already have our quadrant 2 answer. The calculator gave that to us. Now we need to get our quadrant 3 answer. That's why we wanted to figure out the reference angle. So here's our reference angle. We got that from 111. To get our quadrant 3 angle, we would do 180 plus the reference angle. So 180 plus 69 is 249. So there are two answers, 111 and 249. So we covered a good variety of questions in this unit. Just be aware that there could be other types of ones. This isn't everything. So look over your review sheets, and that should cover everything.